G'day everyone, just coming back to talk a little bit more with our bivariate stats. You'll see one of the activities you can do on residual plots. This may be useful for you when you're working on any of your IAs and one of the other subjects. And it's also just useful for when you're talking about your maths and if you ever try to do a modelling type of scenario. Residual plots, what they are is once you've found your line of best fit, a residual plot will plot the difference between each point and the predicted point for that particular x value based on your equation, your line of best fit. So when we actually did that and we were finding those differences before that we talked about in the first video back in bivariate stats, those differences are called residuals. And what we're doing is once we've got the line, the actual line of best fit that we've calculated, the least squares regression line, we can actually plot the residuals, and it can tell us a little bit about whether our model is a good model or not. What we're looking for, hopefully if we have a good model, is that there's no particular pattern in the residuals. This example here, you can see the residuals initially start above, then they're all sort of grouped below in the middle, then they're above again. That's suggesting that maybe a linear model isn't the best model for that particular set of data. So it steps through an example, and when you click on the links in the textbook here, we've just got, 5 points, and we found the regression line there. To find the residuals, we calculate what the y value is expected to be for each of the x values. So the 3, 4, 6, 9, 11. There's the observed values, they're the same ones we had before. The predicted values are values obtained by putting the appropriate number in for x. And then the residual is the difference between each of those. You can then draw the residual plot if you like, or you can use your calculator to calculate it as well, and it will plot residuals. What's interesting is, again, we want to look for whether or not there's a pattern. You can do a couple of example questions there. I'm not too worried about that. I think you'll be able to match up. You know, here we've got above, below, below, above, above, above. So you just look for the residual that goes above, below, below, above, above. And you look for the right pattern. And one of these is going to match one of these. They're not all positive residuals. You rule out C. Are our residuals, does it start a tiny bit above, a tiny bit below? No, that's actually starting quite a bit above and quite a bit below. You can see this scale here, 0 to 0.5, that's almost right on. Oh, actually we've got a 0 point down here that's well below, so definitely not fitting. So we're left with these two. Well, the first point down here at 0, that's going to be well below my line, that looks like it's going to cross about 2.5 or 3. Here's a point that's 2 below the line, that's looking about right. Oh, this one is 2, so we check our next point. Oh, when x is 1, it's predicting a value of about 7, which is maybe 2 above the line. So I'm looking for a residual that's 2 above the line. Well, this is 4 above the line. This one's 2 above the line. I'm saying this one's looking probably the best. You go ahead and you check it with the other ones. Here it's about 4 above, 3 or 4 above. Yeah, that looks about right. Whereas part B, the last point, the very last x point, is below the line. Clearly not right, so you could pick your right answer out of there. Not too concerned about that. The important bit is this a good fit or not? Here, the residual plot, here's my line of best fit. I look at the residual plot, there's no real clear pattern. I mean, it's alternating a little bit, but there's no real clear pattern that you would say suggests this might not be a good model. This linear model seems reasonable. It's a moderately strong correlation. That's probably a reasonable model. With the second example here, those points do not look linear, do they? Even though the correlation might actually be quite the same, you can see when you plot the residuals, there's quite a difference there. This suggests that maybe it's a non-linear relationship and we need to look for some other relationship. They step through another example there, and you can see again here, although it looks fairly close, everything's really close to the line, it looks pretty good. There's a clear pattern in the residuals, which means it may not be as appropriate. There might be something else at play there. That's all I really wanted to say. Just be aware of that. Plotting residuals is a really good thing to do. If you do it in any assignment, make sure you talk about the graph that you've included so that you're aware of it. If you're doing any sort of modelling situation, a look at residuals is useful. All right, that's all I wanted to say. Have fun. Bye.